Good morning to all. Yeah, good morning. Today we will discuss about general theorems of moment of inertia. Okay, so there are two general theorems. One is called perpendicular axis theorem, and the other is parallel axis theorem. Okay, these are the two general theorems of moment of inertia. We will discuss one by one. Let us first discuss about the perpendicular axis theorem. Say we have a plane lamina. Say this is the plane lamina. Okay, so we may have three different axes. One say x axis. X axis may be the axis of rotation. Another may be the y axis, say y prime. Say x and x prime and y prime. These are the two perpendicular axes. Okay, and these axes are on the plane itself. Okay, now another axis may be the perpendicular to the plane itself, and this all three axes, say this perpendicular axis is z prime. All these three axes intersect at one point, one single point. Okay, say this is the single point, say this point is O, and is the center of mass of the lamina. Now what this perpendicular axis theorem says is that the moment of inertia about this z prime axis is equal to the sum of moment of inertia of this lamina about x prime and y prime, provided this z prime axis is perpendicular to the plane of lamina, that is perpendicular to this two mutually perpendicular axes x prime and y prime. Okay, and all these three axes must intersect at one single point. Then this theorem says that moment of inertia about z prime is equal to sum of moment of inertia about x prime plus about y prime. This is the theorem. Okay, we can also prove this theorem. Let us try to prove it. Let us assume a single particle here whose mass is small m, right, or say m suffix I, or this may be considered as the point mass, and suppose the distance of this point mass from the x axis is say y, small y, and the distance of this mass from the y axis is suppose x. Then the coordinate of this point mass will be x comma y. Okay, if we assume that this O is the origin of this reference frame, then moment of inertia of this particle about x prime axis, this is x prime, and about y prime axis. Let us write it. So moment of inertia of that particle about x prime, okay, this is equal to mass of the particle and distance, square of the distance from this axis x prime axis. Okay, this axis. So distance of this particle from this x prime axis will be y. Let me call it, this is y prime square. Similarly, the moment of inertia of the particle about y prime axis, let me write it, y prime is equal to mass of the particle mi, and what is the distance of this particle from y axis? Okay, that is x. This is x square, xi square. Okay. Again, what is the moment of inertia of this particle about this perpendicular axis, that is z prime? Then before that we need to find what is the distance of this particle from the origin or from the z axis. Say this distance is r, then moment of inertia of that particle about z prime is equal to mass of the particle and square of the distance, let me call it ri. Say this distance is the ri. Okay. Now since coordinate of this particle is x and y, so r will be mi, this ri square will be xi square plus yi square. That means I z prime is equal to mi xi square plus mi yi square. Okay. So what does it means is that moment of inertia of that particle about z prime axis is equal to the sum of moment of inertia about x prime axis and y prime axis. Okay. Now this whole plane lamina can be assumed as composed of such particles. Okay. If it is so, then the whole moment of inertia of plane can be written in this way. So, moment of inertia of whole lamina will be equal to sum of moment of inertia of such particles. Okay. That is sum of mi xi square plus mi yi square, where I varies from 1 to n number of particles. Say this lamina composed of n number of particles. So this will be equal to sum of mi xi square plus sum of mi yi square. That is, this is the moment of inertia of the plane of lamina about y axis, that is y prime, and this is the moment of inertia of the lamina about x prime. Okay. That is, we can write sum of that is, we can write the moment of inertia of the plane lamina about this axis, about the perpendicular axis z prime is equal to the sum of moment of inertia, the moment of inertia of whole lamina is equal to the moment of inertia, sum of moment of inertia about x prime and y prime, provided these all three axes are perpendicular to each other. Okay. This is the perpendicular axis theorem. Now let us try to understand what is the parallel axis theorem. Suppose we have the plane lamina say this is the plane lamina, and there is an axis passing through the center of the lamina or center of mass of the lamina. Say this axis is let me call it x prime, say, and there is another axis through the lamina but not through the center of the lamina. Say this is the another axis, let me call it y prime. X prime is the axis which is passing through the center of mass of the lamina, and there is another axis of rotation which is y prime. This is parallel to this axis. Okay. And suppose distance between these two axes is d, and suppose the mass of this lamina is uniformly distributed over whole lamina, and say total mass is capital M. According to this parallel axis theorem, moment of inertia about this axis, that is y prime, is equal to the moment of inertia about this x prime axis plus product of mass of the lamina and square of the distance. Okay. So let me write it. So moment of inertia about of this lamina about y prime is equal to sum of moment of inertia about x prime and product of the mass of the lamina and square of the distance. Okay, this is the parallel axis theorem, and this can be applied to any axes which are parallel to each other. Okay.